Hello, class. This is just a kind of like a bonus lesson, if you will, talking about some ideas and looking at two more practice transformation questions. So the question is, what are the transformations that are happening to both of these graphs? And when you look at it like this in these forms, it starts to make you question what's happening. And so, like, clearly they're not the same thing. The top one is 3x minus 27, the bottom one's 3x minus 9. The question is, which one has a horizontal shift to the right 9? Um, they do both have a horizontal compression, not a stretch, a compression. But really the tricky thing is maybe which one's not in the right form. And when you look at it, g of x actually isn't in the right form. If you want to rewrite g of x, you can rewrite it like this, 3 bracket x minus 3, noticing that when you expand this out, like if you distributed the 3, you get 3x minus 9. This is actually the right form. And this happens whenever you have a k and a d value. So a k value that's not 1 and a d value that's not 0. And so in this case, they're both horizontal compressions, but this one's a shift right 9, and the second one is a shift right 3. So something to be aware of. If you ever see something like this, you do have to fix it and put it in this form. This looks like a right 9, but this is. And so this is actually a right 3. Question here, like we can look at together, what are the transformations? So we've got 1, 2, 3 stretch, compression, reflection transformations, and then one shift. So we look at the base points are your 5 base points of the V shape or the absolute value shape. We'll ask the question, what's the negative and the 3 do? What does the 1/3 do? So you get the negative sign does a vertical reflection and a vertical stretch. And the 1/3 is a horizontal stretch. And you should see each one of these points being horizontally stretched out 3 and then vertically stretched 3, but then also reflected at the same time. And so you can do all of that in one step by multiplying the x values by 3 and the y values by negative 3, and then looking at these points here. So you can see, like, vertically it's been stretched out, horizontally these points have been stretched out, and they've been reflected. And then the shift right 2, you just move each point to the right 2, and there's the new graph. The next one is a reciprocal graph. So we start with the 6 key base points and approaching those asymptotes at x equals 0 and y equals 0. The 2 is a vertical stretch. You can do that by multiplying all the y values by 2, so doubling them, and you can see, you don't have to show the table of values, you can see that the heights from the x-axis just get doubled each time. And then you've got a shift left 4, so the vertical asymptote shifts left to x equals negative 4, and vertical shift down 1, so the horizontal asymptote shifts down to negative 1. And then we can plot those orange points, so those stretch points right on that graph, by taking every one of those points, shifting left 4 and down 1, or looking at that same pattern, over 2, down 1. If you look at this as the axis, you go over 2, down 1, and so then there's your new function, or your fully transformed function.